Hello and welcome. In this video, we're diving deep into advanced concurrency concepts within the Linux operating system. Concurrency is the ability of a system to handle multiple tasks seemingly simultaneously. This is crucial for modern applications to ensure responsiveness and efficiency. We'll explore how Linux manages concurrency through processes and threads. Processes are independent execution environments, each with its own memory space. Threads, on the other hand, are lightweight units of execution within a process, sharing the same memory space. The benefits of concurrency include improved system responsiveness, better resource utilization, and the ability to handle multiple user requests concurrently. However, it also introduces challenges like race conditions and the need for synchronization. Alright, let's delve into the thread lifecycle. In Linux, threads are typically created using the PIA-threads library. The lifecycle includes creation, execution, waiting, and termination. Threads can, well, be in various states such as running, ready, blocked, or terminated. Understanding these states is crucial for debugging and optimizing concurrent applications. A race condition occurs when multiple threads access shared data concurrently, and the final outcome depends on the order in which they execute. This, unfortunately, can lead to unpredictable and erroneous results. Imagine a scenario where two threads are incrementing a shared counter. Now, without proper synchronization, the final value might not really be what you expect. This happens due to the interleaving of instructions, which can lead to unexpected results. This clearly highlights the importance of thread safety. Mutexes, also known as mutual exclusion locks, are used to protect shared resources. They work by allowing only one thread to access the resource at a time. This in turn prevents race conditions and ensures data integrity. When using a mutex, a thread must first acquire the lock before it can access the shared resource. Once it's done, the thread needs to release the lock afterward. This ensures that at any given moment, only one thread can modify the shared counter, effectively preventing race conditions. Semaphores are another synchronization primitive that can be used to control access to shared resources. You see, unlike mutexes, semaphores can allow multiple threads to access a resource concurrently up to a certain limit. Semaphores are particularly useful in scenarios where you need to limit the number of threads accessing a resource, like, say, a database connection pool. This can really help prevent resource exhaustion and, well, improve system stability. Bash provides several tools for managing concurrent processes. One very common technique is running processes in the background using the ampersand symbol. You can use commands like and to manage background processes. The command lists the active jobs while brings a job to the foreground. Oh, and resumes a suspended job in the background. The command can be used to execute commands in parallel. This is honestly quite handy for tasks that can be divided into smaller, independent units of work. For instance, you can use to compress multiple files simultaneously. This approach can significantly reduce the overall processing time. The command is a powerful tool for monitoring processes in Linux. You can use it to view process IDs, CPU usage, memory usage, and more. It's incredibly handy when you need to keep an eye on what's happening under the hood of your system. For example, you can use to view all processes running on the system or to view the threads within a specific process. These options make it easy to filter and focus on exactly what you're looking for. It is an interactive process viewer that provides a real-time view of system resources and processes. It's a great tool for identifying resource-intensive processes and threads. You can easily see CPU usage, memory usage, and the number of threads running for each process. This helps in diagnosing performance bottlenecks and optimizing your applications. In summary, concurrency is a powerful tool for improving system performance and responsiveness. Understanding concepts like threads, processes, race conditions, and synchronization is crucial for building robust and efficient applications in Linux. Thank you for watching. We hope this video has provided you with a solid foundation in advanced concurrency concepts in Linux.